Okay, so it's March 3rd. Addison will pop back in here. I expect he'll do that just as I'm getting going. And the first thing on my list is actually something I posted to Slack. Anyway, so got the screen shared here. Unfortunately, this computer super needs a reboot, so I'm just gonna have to hide this in the corner where you can't even say snooze. But we'll reboot after the meeting. It's weird. I've been logged into Goose and I haven't seen this.
I've been seeing.
You've been seeing it?
I've been-
All right, well, that's not a big deal. Okay, so I only have a few things to talk about today. The first of which is this fairly exciting news that the LiDAR on the iPhone is getting an upgrade. So the LiDAR that's on these things now is a little on the weak side, in my opinion. And so we're going to be getting a new one that is substantially higher resolution. So did I put it on here? I pasted it in the, there we go. So the old one was essentially 576 depth points. So that doesn't amount to very high resolution at all. But it looks like the 556, if that is indeed what's going to come along, is going to be substantially, a 640 by 480 ish kind of a pixel size. So that's awesome. The difference in clarity between what we have and what we're getting is pretty great. So I'm pretty excited about this. And then apparently an upgrade to the infrared as well. I didn't focus too much on that, but we did a lot of mapping with the iPad back in the day. Chandler kind of tested a lot of the stuff out with the iPad and the LiDAR system. And it works okay, and it works pretty well for small areas, like a room size thing. But it kind of fell down a little bit when you start to get to like bigger areas. It had a hard time sort of stitching everything together. So it would start to fragment, or it would start to kind of not quite join back together. This came across my transom this morning. Have we seen this?
Maybe that might have been something that I looked at and I was like, I don't know if you can use this, but I only looked at it for 10 seconds. So
Okay.
or it was something
I
else.
literally found this 2 minutes before I came in. I was like, oh, I want to throw this on for those guys. We'll take a look and
I
see.
think it might have been a very different kind of plate pad, not a LAS.
Okay.
I think that's why I was never mind. But or maybe it was a completely different plate pad. I don't know.
Okay.
Yeah, we can just check.
Yeah, we'll just spend 1 second and kind of
Similar to that.
look it over. All right, the big thing that I did this week with the help of Addison and Lindsay was georeferencing the CID GeoSLAM point cloud. We had done a GeoSLAM scan of that, or more correctly, hired Todd Ogle's team to do it. So they sent over 2 undergrads with the GeoSLAM and walked around the interior and the exterior. I aligned the interior to the old interior that we had, but we never aligned the exterior to its real world coordinates. So Addison and I did that on Monday? And started by getting the VGen LiDAR cloud, brought it into Cloud Compare, drug the CID model in. And the way it works is basically, when you load a model into Cloud Compare, it's got that initial thing that says, how do you want me to handle the offset, right? Because everything is in geographic coordinates, so it's way far away from the origin, hundreds of thousands of meters away from its origin. So it just subtracts that out to kind of bring it back to near zero. So when you do that, the sort of local coordinates are kind of zero-based, and then when you drag in a new model that hasn't been georeferenced, it just sits in there somewhere, right? So the steps are basically, you kind of drag it into place, and then there's a button, and I forgot to put this on here again, but there's a apply global offset. So you can sort of take whatever the offset of the real georeference model was and apply that to the new thing you get in. So it's just a one-click operation to do that once you get it set. So then we got it kind of roughly aligned and roughly in place. This is actually isn't the LiDAR underneath of it. It's a Bing image which the Bing imagery that we had is the best resolution, newest one that has any part of the footprint of this thing. So it was built, it came online about a year and a half ago, under construction 2 years ago, probably when this photo was taken. And there was enough of the skeleton there of the building to be able to kind of get it more or less in place. Now, the Bing imagery isn't super precisely georeferenced anyway. That would get us to within a meter or two. But to get it to the centimeter scale, we did one more thing, which is we collected GCPs. So Addison and Lindsay went out with the EMLID Reach and collected GCPs in the physical space where we could spot things. So one of them, this is like a wall. And so I had them collect a point kind of right along this edge. And so they collected 3 points. And so that was the first one. The second one was the opposite length around the other side of the wall. And then the third one was in back of the building on that little, what was that? Is it a wall?
Yeah.
Little wall. And then because the point clouds are in orthometric heights and the GPS is in an ellipsoidal height, you just have to apply this offset to get them to match. So there's a nice little API that NOAA has that you just put in a URL with the latitude and longitude and it spits out this little text file. So that's the easiest way that I've found. This is referenced on the GPS wiki on the lab website if we need it. And then the last bit there was to transform those into UTM coordinates. So the GCPs come in as latitudes and longitudes. Did I show that? Okay. So they come in as latitudes and longitudes, and then you have to convert those to UTM. So they get in meters. So they're in the same projection as the LiDAR data. LiDAR data is almost always going to be in UTM. Sometimes you'll find it in state plane, but I have never seen one in latitude and longitude. I'm sure they exist somewhere, but essentially just recalculating, reprojecting the points. Cloud Compare isn't a GIS. It can handle coordinates, but it can't handle projections. So anything that goes into there has to be in the same projection. So the upshot is that they collected these 3 points, and then you sort of you add these in there, and you can increase the point size of these. So instead of looking like points, they look like cubes. They're easy to find. And then the goal is you just kind of shift the point cloud around until you get them to match. There are tools that kind of will do this for you, but it's easier just to do it by eye, and it's less error prone. So this one is actually not where it should be. It should be here. So this is kind of like mid alignment. I aligned to the first one, like drug the point cloud to make it match here. And then the second one is a little bit off. So then you just gotta like shift and rotate just a little bit. You can see that we're off by a little bit, not in translation and rotation, right? So you need to kind of like use the one as a pivot point and kind of rotate it in. And then the last one, once you lock those in, and as long as there isn't any tilt, then the third one should just slide right in where it goes and can function like a checkpoint, which indeed it just matched up perfectly. So the upshot is we took a point cloud, a georeference point cloud from VGen like this, and then added in our new formerly unreferenced point cloud that looks like that. And I think it turned out great. You can see the, if we wanted to take this a step further, we could do it, but like, whatever trees that were in there before they built the building are still in the model, you could go in and scope those out if you wanted to, but not necessary. The goal was just to make it align. And I think it dropped in quite nicely. And that's it for me. I didn't have time to put my goals in this morning, so I was in a rush. But my goals are to take it easy, finish a paper with Colleen over break, and then try to get the component for the UI for you guys. Yes. Right, we added you to the folder, right?
Yeah.
You must have, because you saved it. If you could save these as PowerPoints, export them as PPTX, because I archive everything.
So it should be in Google Slides, I think.
It is, yeah, but if you can then save it then as a PowerPoint and,
Okay, got
yeah,
it.
that'd be great. Isn't that take action button just like seductively calling you, like, press me, press me?
The PDF or the PDFs?
No, you don't worry, it's now.
Oh. I was thinking of opening everyone's now.
Oh, no, don't do that.
Yeah.
Okay. All right, it's going to be super short. The one thing was Rebecca and I, like this Wednesday, like merged all our changes.
In like an hour.
It took like an hour and like we went line by line.
Yeah.
Because like GitHub was like, it's too complex to merge by
I
automatic.
wondered.
It's because we have been doing our own things for like weeks, so.
Yeah.
Okay.
After this, it should be like much better because like we're going to do it every week.
Okay,
That's the plan for that. The second thing was, yeah, so the change, right? The point cloud change works. So you see that white text box thing?
Yeah.
If you put the link of the text box, so here what I did was, for now, what I've done is the original one, right? It's the Southwest one, right? So right now, this is the Southwest point cloud.
Mhm.
Now, if you put like, if you put this one, what do you call, like a URL like this one? So like here, what do you call it? I was first trying it with constant, now it's like variable. So if you put this name in this, it would like move to that point cloud. If you have some other last point cloud that is available on web, like GitHub or something, you put that here, and then you click on the purple cube, and like if the point cloud change. Okay, they're just cubes right now, not buttons,
yeah,
because I just left the beautification part for the later.
okay.
But yeah, so now the import part at least works. I have an idea about how the upload file would work, but what do you call? I'm first thinking of making sure we can export the last, and then I'll just like add the import file feature.
You know, another interesting way to do the URL loading would be to pass it in through the URL when we load it up, right? To have like the whatever question mark, whatever, and then have it as a parameter in the URL. A lot of things do it that way.
Yeah.
That might be pretty intuitive, and then that would pass directly, and then there wouldn't be much need for UI. Because I imagine the use case is going to be sort of like you start it up, you load the point cloud, and then you jump into VR, right? So it's less important to be able to swap it out in VR than it is to kind of set it up.
That will actually be easier, right? Because for us, right, URL would be something we have at the very beginning, right?
Right.
So it's much
easier.
easier.
Reload it. It's running it like twice, like loading the thing twice just because of the way we have it set up right now.
Because like we need to be able to change the URL, right? So
Right.
in this case, like it first loaded this cloud, right? Then you put your URL, then you click the cube. So it again has to remove the whole point cloud, reload the whole point cloud.
Right.
So if we actually go the URL, that's completely that would technically be easier performance wise.
Okay.
Because you don't really need to save any state when you like change point clouds.
Yeah.
The
Okay.
The only other thing is, if you want to load something, so it's probably not ready yet, but a way to load it locally, right? So I've got maybe this isn't even, I don't know, maybe it's possible, maybe it isn't, because lasloader.com does it, or was it lidarview.com can do it. Like if you've got a point cloud on your machine that you want to render, you don't have to. Do we have an idea of how to do that?
I mean, theoretically, it should be the same because everything's like that. You know, you just wouldn't do like HTTP. You would just give it
Okay.
C
Yeah.
Okay.
and
Cool.
give it the local thing, but I don't know if it would work in our testing environment.
Right.
So I don't know.
But if we get something pushed up to
Yeah.
GitHub, then we could try it out from there. All right. Things for the next couple days then.
Yeah, for the only thing with the file thing, right, is so right now when we say URL, right, it doesn't really matter much because like you're getting the pointer from the internet itself, right?
Right.
But like if we are going from the URL way, then uploading the file would be tricky because this thing, right, is technically on the server side, right? So like, you will have to place the files in a very specific sense. Because I remember like XAMPP, right? When I was running it through the XAMPP and I went to localhost on that. So the thing was, when I tried putting in a file name, which was originally like, so it would not take the file from me. It would just search my XAMPP folder for that, the place where the code exists.
Mhm.
So like, it would look something like it would be searching our server for that file. So we've tried to figure out how we can upload it and then we can like make it that available.
Yeah, we've got, I mean, so we can use anything that's already been uploaded. We've got a few of them now somewhere, and I can add a couple more. I think the use case of like someone puts it online somewhere, because then it might be like an Amazon thing, or like it could be anywhere, right? So I think both ways are probably good. One, being able to access it via URL, and then one being able to load something locally. And those are the only two use cases that I can imagine.
All right. Yeah, so what do you call it? At first change it to the URL part.
Okay.
Okay.
And you can leave that the way it is. I mean, it's not a bad idea to have it in the VR system also. You've already figured it out, so I wouldn't get rid of that, but
You could make like a loading, like an initial screen where it's like, if you don't put anything in the URL, it can be like an upload button.
sure.
And then you
Yeah.
upload it and then it takes.
That's a
you
good idea.
to
Yeah.
download something to full.
Yeah, we can actually do that. I think
More
URL.
user friendly.
Yeah. All right.
Cool.
So that's basically it. My goal would be like to obviously make that change and like get the file system is the second thing, and the third thing is like the exporting part. Exporting, I was looking a little bit into the export yesterday, so it should be about done like by the end of spring break.
Okay, still works for CSV, and
Yeah.
you're just trying to get it to work for LAS.
Yeah.
Very good.
Okay. So I've been working on changing the classifications, like actually having it show up as changing it. And so the first thing I did was getting the raycaster up, and very luckily it just returned as part of the raycaster an array of everything that it intersects with,
Whoa,
including the
that's nice.
indexes of the points. Because I was also worried about this, that it would
Yeah.
just tell us you intersected with point cloud,
Yeah, that
but
would
no,
Yeah.
it tells us which points.
Well, that is
It
a
was like,
lucky
you
draw.
intersected with 28 points. And now I'm thinking about it, I'm pretty sure that it's the indexes of like the classifications array, but
Yeah, yeah.
based on my testing, I'm pretty sure that's correct, because
Wow.
it does seem to like change what you touch.
Well, that'll be fast. You don't have to like,
Fast is relative, that's in the second part of the thing. It could be fast, right now it's not. So then I was like printing out the classification values of the ones that it intersected, and
Uh-huh.
then it changed them from 2 to 7, because I just picked 7 because it's easy to see and none of them are 7 right now. But then it wants re-rendering, but then I made sure it ran the update function again, and it renders. And I drew a little face. It took a really long time.
that's awesome.
Because I've also attached this like sphere as like a child of the left controller, and so then the raycaster is the sphere now, so you can change the size of the sphere. Theoretically,
Sweet.
every time I try to make it bigger, it just like doesn't show up, but that's yeah. So I've been trying to test it on the VR headset to see if it like is more usable in the real setting, but it's not letting me.
Oh.
It was yelling, like I was able to get to the point where I could access it on the VR, but then it was like, you didn't do it securely, so you can't have access to the device sensors, which is kind of like necessary to do VR.
Yeah,
So it was just sort of showing me it in 2D, which defeated the purpose.
huh, okay.
So then I tried to set up HTTPS on XAMPP, but it doesn't work. It's still giving me problems. And then I got really frustrated because I hate networking, and try again later.
another experience.
Now that kind of stuff is super irritating.
Yeah.
I feel your pain.
I've gotten to the point where I know I'm not gonna get anything else done, and so it's just like, that's a not right now problem.
Yeah,
So that's a not right now problem.
okay. And if we push all this stuff to GitHub, we should be able to try it out there. It's not great
Yeah.
for development, because then you're
But
kind of
yeah, you can
jumping
still
back
see
and
if it
forth, but.
works. So then I'm working on looking into the performance, because it's getting so slow that it's almost unusable. So I ran this little memory snapshot thing, and so this is before the plant pad was loaded, like all of the memory, and this is what happened after it was loaded.
Oh,
178 megabytes of array buffer, which is something that is a lot
Yeah, okay. So now we're hitting like,
performance.
yeah. All right, so this is
5
where
million
like
bytes is a lot.
Poetry or something else, like this is why Poetry, right? Like,
Yeah, and Poetry also has things built in, like it doesn't always load every single point, like it starts out like small.
right.
So that we're gonna have to start doing things. Because loading all of them all at once, all of the time, isn't working very well.
Okay.
Yeah, like skipping like every alternate point sort of thing. maybe,
Yeah,
like,
or just like only, I don't know.
Well, I mean, okay, so in terms of the criticality of the problem, I mean, you can always, for now, right, this is what's the right way to do it,
Mhm.
like overall, and right? Smaller sections of a point cloud, right? So
Yeah,
like,
that's one solution.
I mean, that's not ideal, right? That's
Yeah.
not where we want to be, but like for now, I'm a little less worried about performance unless it's
Mhm.
like we're hitting a wall real early. And so are you hitting it on like the tree?
Tree is about the same size as the PDAL. It's like,
No way.
it might even be bigger, honestly. Like it's not that much. There's just a lot of points.
Oh, because it's a floating, yeah, okay.
Yeah, there's a lot of points.
Huh.
But yeah, no, so there's I found this stats component where you just add it to the ape scene really easy, and then it pops up as a like window which tells you everything.
That's cool.
The FPS after the point cloud build is 0.7, which is why I didn't
Nappy.
get anything done.
Yeah,
But it always
wow.
tells me that it wasn't like the control, like the classification that wasn't working, it was just moving at less than 1 second.
See, that's a bummer because I was kind of hoping that like A-Frame would sort of handle that for us to a larger degree. Like it would be smart enough to like,
It's not that smart. Like they have an asset management system, which is meant for a lot of different entities and it can help with the loading and stuff, but we only have one entity, so I'm not sure that's gonna be helpful right now. However, there are things,
so what does, I guess, okay, so,
you can pretty easily tell what's in the camera's view, so you can use that to like only render them, maybe.
yeah.
I don't know how to only render some of the points. Actually, no, that's
Okay,
possible.
well,
That's
it
possible.
might be worthwhile looking to at, taking another look at like the COPC viewer and that
Mhm.
stuff to see what they're doing.
I'm pretty sure what most people are doing is like definitely only rendering the things that you're seeing, because that's a pretty solid like
Yeah.
3D just like practice.
Yeah.
Don't render unnecessary things because rendering is what takes up all of the time.
Yeah.
Um,
Well, why don't you spend a little time looking at that code to see, because now that you guys are both far enough now that you know what to look for. And so I think the comparison should make a little more sense. I think that'd be time well spent.
I think that would help a lot, and then maybe even rendering it in like different things. So I was just on Google Maps this morning and I was thinking about how it like, gets you higher detail when you zoom in.
Yeah.
And so we could think about doing that kind of thing.
I'm surprised that it just doesn't get handled a little bit automatically. Like, so the New York Times mesh viewer must have a similar problem. What do
That's
they
what
do?
all of the code was. We saw it do that in the component code, which we commented out and then deleted because it wasn't a one-to-one match.
It was more tiles.
But
like,
yeah, they had a lot of code saying which tiles to render and what based on like everything.
Okay.
Selective rendering as well.
Yeah.
Okay.
mhm.
All right, so that's another strategy too, is to go back and
So
look
they
at that
were
stuff
doing
and
that, but
see.
it wasn't.
Okay, that sucks.
Well,
It's not a big deal. It's just
giving people control
every
over it
3D
is, like,
scene always has this problem. So like, why does each individual developer have to solve this for a point cloud, for a mesh, and for this, and for like,
I mean,
it's a general
I
problem. It
solved
should be
for
tackled at
the,
a
like,
general level.
entities and stuff.
yeah,
And there's like fairly simple ways to do it, I think. The camera frustum thing, I think, is the simplest way to do
Okay.
it. It's more just like an if in view render. I think.
what if we? I'm gonna have to think about that some more. So your point, the second point, seems better suited for a lot of modeling, and we only have one entity.
It was saying.
I mean,
like,
that's what
put all
Poetry-
your entities in.
That's
there.
what Poetry does, is Poetry is essentially this like, let's make a billion entities instead of,
Yeah.
and then maybe that's just how they get away with it. Is there a easy way to calculate an octree on it that would do it? That's Wince means probably not.
I'm gonna call it easy.
Yeah,
That would be completely restructuring the data.
yeah.
possible, but not easy.
So another another idea is COPC is explicitly designed to essentially do this, to like apply a structure to the data so that, but then that would mean sort of looking at the COPC reader, which we probably should do, because maybe that just solves this problem, right?
That would probably
Maybe,
help with the loading, because the loading takes a long time, but that's like less of a problem in my mind than the rendering. Because I don't think it's a problem with the data structure, it's the fact that we're rendering 5 billion things in the screen constantly, which computers don't like.
yeah, I think that's also worth another look, is the look at the COPC reader that we found and just see what they're doing with it. Yeah, all right.
Yeah, there are ways to make it faster, you just need to actually start focusing on them, I think.
Yeah.
Not just look at the code, there's probably a lot of things that can be faster in the code.
Yeah. I guess like I'll also look through the promise all thing.
Okay,
That's it.
very good. All right, great. Coming along. All the components are in there. It's just now
It's just like,
making it better. Yeah. This is good. I mean, so if you had like 100 points, it would
Sure,
render at full
I
speed. You probably wouldn't
I
have
could
any.
probably try that, but I bet it would.
Okay.
That would be a good test
You got it?
to confirm that it is in fact a number of points. I'm pretty sure it is.
Yeah. If it runs at full speed at 100, we'll know a little bit of what the problem is. We'll know what not the problem.
It makes it, while it's loading the plane cloud, everything's super fast. Once it loads, then it's like, oh no.
Hmm.
So I think it's just trying, because every time you move the screen, it has to re-render everything.
Yeah. Okay.
So this week, so the Clear One attachment camera came. So got to play around with that a lot. Figured out how to change some like small setting stuff like Celsius to Fahrenheit. And then I was trying to stitch some things or some of the images together with Microsoft Ice, which is what this is. So yeah, I mean, that was probably about 7 images of that wall. So it didn't really come out well. It didn't really know what to do with it, but also the problem was it didn't have a set minimum and maximum temperature value. So it was just kind of like automatically adjusting it per frame, which didn't load well. So then tried again. With the outside of Wallace. I think I took about 50 pictures, but Wallace is too, it looks the same too much. So I think that's why it didn't run very well. But it was able to have all the same minimum and maximum values. So that shouldn't have been the problem. And the next step is to run it with Pix4D.
What's the resolution of this data?
I don't know.
Oh, of the of the photos or of the
Photos.
Yeah.
The thermal.
I don't know. Is there a way to find that out?
Yeah, you can just look at the properties of each image and see what that is. But it's based on the whatever it is, the Lepton one. So it's 160 by 120. No, wait, is it? We looked at a couple of different ones.
We did, and I remember I wrote it down in another lab report.
Yeah. Yeah, well, now I forget.
Yeah.
We talked about getting one that was slightly better than the 160 by 120, but I don't remember if we did.
I don't think we did.
One thing, just to make sure, like if you're running this data in Pix4D, like Dr. Meher, do you remember like when we first figured out like how to process this thermal data in Pix4D, like the front of the wall assault, like we took the initial parameters of the RGB cameras and then applied into the thermal cameras. do you remember that?
Barely. Yeah.
So there was like,
memories.
so we had to run the initial processing for the RGB images first. And then it would give us the initial camera parameters for all the RGB images. And then we would take that,
Oh, like the locations.
the locations,
Yeah, yeah.
yes, yeah, the locations, and then apply to the thermal cameras, like maybe change like make a little bit edit in the text file and then replace it in the thermal folder.
Yeah, I remember that.
Yeah, that one. So maybe like when Lindsay is gonna run this thing, she's gonna do that process again.
Well, and the only thing is that I don't know, did you get RGB images?
I
Did
think
your-
we had talked about like trying to separate them, but
So, so we actually did this twice. So we did it with the Lab Clear View R, which is what we had done. And then this is from her little tiny thermal camera that goes on the
okay.
iPhone. So so he's right, when you run it, you're gonna wanna make sure that it takes both an RGB photo and a thermal photo at the same time, ideally, which the apps can do that. You just have to like play around with the app and then the idea is, and then I think we had talked about, I don't know whether these are going to get geo-referenced, like they might not. Your phone has a GPS, so it might be smart enough to attach it, or it might not. And in fact, if that happens, you might get lucky and the thermal photos themselves might get geos. Which when we did ours, we weren't using the GPS antenna.
Even if we use the GPS, so there was an issue with the distance of the camera and the object.
Too messy and too
Yeah,
small.
so we actually I actually contacted the Pixel support, and they mentioned that there has to be a certain amount of distance if you want to run the thermal images like the RGB images. Like you just give them and it will automatically run them, which actually happened for us when we were processing the photos of the baseball field.
Yeah.
Like right beside the community center. So we just had to run it and it was run smoothly. But when we were running the photos of the Wallisell facade, it was complicated. Like
Yeah.
it took like several days to figure that.
I think at one
thing
point
out.
too, we had like just manually guesstimated the distances, right? Because we're like, well, each square out there is 6 feet or whatever it was, and we just took it every square so that we would know exactly. So we just like manufactured a little text file that was like artificial coordinates.
Yeah, and the Pix40 support mentioned that the distance had to be like at least minimum like 40 feet or something. Like
Yeah.
I don't remember the exact number, but it has to be like 40 feet or something. If you want to like run the thermal images like the RGB images as well.
Yeah, the gist of it
Other
is
than that,
because the thermal images are so low resolution
Yeah.
and the contrast on a thermal image is so much worse. Like in an RGB image, you can see a door and a light switch and all this stuff, but on a thermal image, it's mostly the same temperature. So you don't see the differences as much as you do in the visible spectrum. So it's just very hard to get the thermal images to come together. Long story short. So we'll talk about this in maybe our meeting, but one technique is to, when Pix40 runs, one of the things, like you're always looking in folder 2 and 3, right? The orthophoto and the point cloud.
Yeah.
But in folder 1 is a file that says, you know how when you run Pix40, it says it's got the blue dots and the green dots and where it is, where it was. So it actually writes all that out to a little text file that you can then use to like geo-reference your other things. So you just pretend it's like a file that lists all the coordinates of the images. And I think what we did was like go into Excel or a text editor and just find and replace like the thermal file names for the RGB file names. Because it was just a simple find and replace. And then you basically you're using the RGB images to geolocate everything and to get the model made. And then you use that to feed into the thermal model and then make that. And then you combine them. It's a bit of a process, as you can understand. Like,
yeah.
It's actually all laid out, like you have the tutorial.
do I?
Yeah.
Oh, good.
Yeah,
We'll send you that.
like my whole poster was based on that, so it's all laid out there.
Okay.
You don't have to start from scratch.
No, you definitely don't have to start from scratch.
We spend hours, guys.
Yeah, that's parts of it figured out. I was trying to find the files for those. Do you remember where the Wallace facade is? I don't remember where.
I have those, like, I have them in my folder,
Okay,
so it's all organized, I can show you.
yeah, maybe make a copy and put a copy of the Wallace facade stuff into Lindsay's project folder, which is just off of the Neil folder projects and then Lindsay's 3D thermal model.
Yeah, I can copy those folder to your folders.
Yeah, thank you.
Very good.
Like, it just keeps taking control, the reboot.
Yes.
Okay. You have to take action now.
Yeah, it's not messing around anymore.
So the next thing that we did was we went out and did drone flight and GCP collection in one go of it. That was on Wednesday. So the second flight and the collecting of the GCPs went well, but first flight that we tried to do had a couple of issues. One of them was it looked like it stopped taking images partway through the flight. I'm not really sure why that happened. It has happened to us before. I don't think I hit any buttons otherwise.
It's happened now, what, 2 times out of 8?
Yeah,
Okay,
yeah. And so then, but the other problem that we ran into was, so I had paused the mission because there was like people and planes and just had to just wanted to stop for a minute.
it was a strange convergence.
Yes.
There was a plane coming and then that was the offset, and then somebody was like walking their baby and dog through the whole thing.
Yeah.
And so Lindsay wisely paused the mission.
Yeah, so I paused the mission and then I tried to hit continue, but it was trying to do the launch checklist again, which it was failing its own launch checklist. So I'm not sure why it was doing that because it was already in the air. But so then I was like, okay, that's fine. So then hit return to home and it did not return to home. Yeah. I landed it manually.
Oh my goodness.
Yeah, I've never seen that before. Yeah, that's the first time I've seen the return to launch just totally not respond. It's just up there hovering. It's just like
Yeah.
hanging out.
I'm not coming down.
Yeah.
Yeah, so I don't know why that happened, but that happened, and then we tried again with the second flight, and then it ran smoothly the second flight. So
We ended up having to reboot everything, right? We powered off the drone, we shut down the app, we unplugged the controller.
unplugged the controller, restarted the controller, and then everything worked fine.
Yeah.
So yeah.
Did you still try pausing the mission in the middle and
No, we didn't need to, but yeah, we'll experiment with that later.
I think probably normally I have paused missions and resumed them before, and I think the fact that it's not taking photos, it's continuing through the flight plan, so it looks like it's doing fine. But there's clearly some communications problem because the photos, usually you see little icons popping up as it's taking photos, and it just stops doing that.
Yeah.
And stops updating, right? So just even on the app, and then sometimes the weird thing is that it popped back up again intermittently. So did the first, let's call it 50 photos, and everything looks like it's going fine. And then it's non-responsive, and then 1 or 2 images will pop up way down the road. It's very strange behavior.
Which app you were using?
Pix4D capture. Yeah. Is that the one you're using as well?
I actually use 2. It's I use the Pix4D and what was Theo using? The drone deploy. Yeah.
Okay.
I think drone deploy is the most popular one. No. Drone deploy is not free.
It's very,
It's very expensive.
yeah, it's $100 a month or something.
Yeah.
It's pricey.
Yeah, because not only you can capture photos, but you can also process the photos. There's options to upload GCPs and but you can adjust those GCPs or add MTPs or something like that. It's nothing.
And one of the things that, and we should probably try this, it would be worth a $100 one shot, so you can get a sense of how that stuff works. And then in particular, I think that the thermal sometimes the thermal data works really well on
Yeah.
there, but it would work better on Theo's drone than it would on ours because our camera isn't really integrated with the flight controller the way the Mavic is. So I don't know. We can think about
Don't
that.
deploy, like with the free version, you can actually run the flight mission.
Oh,
Yeah, you can't just like use the processing
really?
version of it.
Oh,
yeah.
we should definitely do that.
Yeah.
Great.
And then just goals, by next lab report and just create a time lapse of the thermal images from the FLIR 1. And then finish the next section of the Pix4D training and create thermal facades of buildings. And then I have it up there, but I'm not sure when that'll get done, but I have run Pix4D on thermal images.
Very good. It was a busy day on the field that day. There were people playing frisbee. It was a nice, really warm day, and so everybody was out. And then there were a lot of planes flying around.
Yeah.
On a nice spring day, like people start to get they're like, I'm gonna go fly my plane. So they go to the airport and they start just flying Cessnas all around. It's kind of irritating.
So my presentation is mostly about the presentation I did at AAC. So I went to Arizona with Time to the West, and I wanted to share this resource they showcased at the library in AAC. It's called Map and Geospatial Hub. They have a whole model and a 3D inventory of all the maps they have, and they say they have like thousands of maps from like ranging from like Senegal. So if anyone is interested in seeing old maps, they have a full system where you can like basically see the indoor 3D model of the library. You can like query a map and it basically shows you which drawer it is in. And you can basically click on the drawer and like take out the map. It was really cool.
Wow.
I still think it's more of an inventory system than an actual geospatial indoor system, but it was really cool to check it out. It was really nice. And I didn't realize what ASU is very big. Arizona State University is very big. So this was a workshop I attended. It was a specialist meeting on digital twins. I wanted to share the keynote presenters, and I wanted to share everyone's topic, but the last two are still to be like uploaded, and these will be available because they will be recorded. And I think everyone is going to give like consent to it being shared. It was a lot of digital twin stuff, but I also felt like there was a lot of geospatial analysis being done, more than digital twin stuff. We had a brief discussion. We had a lot of brief discussions on what digital twin has come from and where it is going towards. So these are the keynote speakers, and these are the lightning talk people. And I was really proud to see that there were 2 people from Virginia Tech. Every other university had like 1 representative except Santa Barbara, who had a lot of keynote speakers. But I really felt this was something I wanted to show. And even the lightning talks were really cool. People were there, were working on mobility data, a lot of big data, temperature data, and there was like SCTable, Jack and Benjamin conservancy stuff too. So all of these were like, I think will be of interest to everyone when they get released. I'll share that then. So talking about digital twins, I took a like list of what the major discussion was about and where it is coming from and where it is going towards. So these are just like basically notes to myself. The thing I really like the discussion about is the concept of metaverse and how everyone is trying to go inside immersive reality to represent our world. And we were talking about how like in the first days of the computing, we were inside a room which was full of computers, and basically people thought of like people as living inside a computer. And we are now carrying computers on our own, but we are going towards the digital twin system so that we can go inside a computer again. That was a really cool concept I liked. And the concept of digital twin is basically how any physical entity or process can be looked at in a virtual way. And this was majorly aimed to be a proactive approach than reactive approach, mostly for like emergency responses and stuff, where we don't need to wait for things to happen. We can basically predict things and like use preventive measures. The other thing I really like, I think, yeah, it's like we were talking about twins, and some people said, okay, we have digital twins now, but will we also have triplets? Because someone will make a digital twin, it will just be a simplification model, but that will be for a single purpose.
Mhm.
And another person will model the same thing, but for a different purpose, and
Mhm.
those two are two different twins. So triplets, quadruplets, and the major like talk was about how do we integrate them together. And like to understand digital twins, I read a few papers, but I think this is a very good example of SimCity. I think most of us have like an idea about what SimCity is, where you can basically go do stuff and see what the reaction is. I think this is like on the technical side, it is basically trying to do the same, but we ask them research questions. And these are just note to myself. I wanted to like I listened to a lot of lightning talks and keynote speakers, and then I thought these could be something I will be looking at just to like what they are doing. And this is a table that I made from someone's slide because I thought this was very necessary. Like in the modern era, there has been a shift in how we ask geospatial questions. We were looking at patterns then, but we're looking at processes now, and there's some advancement on like what we are thinking about right now. One thing I really liked about was uncertainty to reproducibility, because we were so concerned with uncertainty in the previous days, but now we are looking at is it reproducible? So this was something I really liked. And then this was from, I think, Tristan Nelson, who is the department chair at UC Santa Barbara. And this was a really cool article which basically talks about why do geographers fit in every data science team. And this was a really cool article, I think. We'll have fun reading this. So a lot of PRs for me. So first domestic flight in the US, first time to the West, first time giving a talk. I was the only student to be presenting there. And to my surprise, I was the only one who didn't have a PhD. There was one other person, and he was the person who brought the funding for the whole thing. And that was something I was like really scared of on the first day, but I was really proud of when I came back.
Awesome.
So this was a hike we did, and I realized that in the formal settings we're just listening to each other, but in the informal setting it's much more better to connect. So I really enjoyed the time there, and this is one of the key features of the hike we went to. Hieroglyphics, yeah. And this was basically before the alphabet were there, so this was really good. I was surprised it hasn't been vandalized yet. I thought people would just like write over it.
Like, I was here.
I was here.
Bob Bobstein was here.
Really cool. I thought like water would wash over it, but it's there. It was so cool.
They like got rid of the black stuff is like really like in like stone stuff, and they like scratched it out, so that's why it hasn't washed away.
Oh, okay.
I saw some of them when I was in Arizona over the summer. They're cool.
Arizona. So I had seen cactuses on like a pot scale. This was 5 times my size. And
Cool.
it was like I really enjoyed
Is
this.
it really 5 times your size?
Yeah.
Oh my God.
I don't have a picture, but Dr. Ken took a picture where he stands next to the cactus and
Oh
5
my
times.
God.
I think was it Addison or Alexander who told me the species of this, and this is not native to Arizona. People like brought it from Europe and planted it there. There was something, and then like more on my research stuff, I was trying to take the percent data, and then I was trying to make it look like that. This is what I have so far, because I'm still looking at a way to get the data into a much readable format, but I think I'm good with the plotting right now. So
Okay.
my goals for next week include spring break, and after coming back from spring break, Ashton and I will set up a time to set up Percept in the lab. Still do this time cube stuff and the regular stuff.
Very good. All right. Thank you.
Do you have a presentation?
No, I don't have. I'll go last. But anyways.
Sure. Addison, you presenting this week?
Yes, I have one. Give me just a second.
How'd you get the warning to go away?
I don't know.
Magic.
Did I do that?
You did. Where's my sharing? Oh, I've got to stop sharing.
There's something.
No, I think I need to be like a co-host or a, oh, it's enabled now. Never mind. Let's see. Is this working?
Yep.
Sweet. I have a pretty quick one this week. Just mostly a lot of trial and error this week. So we'll go ahead and jump into it. So one thing that I was trying last week was trying to make the space-time cube using the hourly summary data. So what I was trying last week was to basically try to make the netcdf using the hourly summaries are in .tiff files. So I was trying to make a netcdf in Arc, like by making like a mosaic layer, I think is what it was called. And that was not the most effective way of doing it because it was just giving me all tons of problems. So what I did this week was basically took the code that Dr. Pingle had written to turn basically the raw data, the one that's generated every second, and making 3,600 images stacked into an netcdf. I was basically taking that and using hourly summaries and refactoring it to make it work with those, so that there's 24 images stacked in netcdf. So I got this working. And then now trying to just make like a space-time cube with this. So I'm bringing it in as basically an netcdf raster layer. And it does make one. I do end up with a lot of problems when I try to do this for some reason. And we'll get to that in a second. So it doesn't actually give me a start or end time. For some reason I can't go back, but that's okay. Oh well. It doesn't really give me a start or end time. So I have to like manually set in what the time is, even though there like is a timestamp associated with the data itself. But I wanted to try to resample it. So there's a couple ways of resampling the data. So basically the cell size itself was too small. Basically, there's just like, if each bin in the space-time cube is a single pixel of data, that doesn't really tell you any sort of like spatial pattern. Because, 1140 by 900 pixels is not necessarily like the best way to analyze this sort of stuff. So there's the resample tool, which I was using, that's in Arc, which I was using in the past, but the resampling options are like not super efficient, and not necessarily what we want, because it's basically taking like nearest neighbor methods or like cubic methods to like actually resample the data. And what we would rather do is do something called a block sum, which is basically just taking the pixel values for like a group of pixels and adding them up. So like this graph here is really good. On the side is like a pretty good way of visualizing that. So this is making, I guess, 9 blocks out of what was 36. So drinking it down by a factor of 4. So I tried this briefly this week, but it was causing me issues in Python. I think I just need to figure out how to like maybe convert the images into like a NumPy data array. And use each TIFF individually, and then like say like for image in like the string of TIFFs, compute the block sum, because I was trying to do it on the netcdf entirely and it was not liking that. So I think I might need to try to do it for the .tiffs, but I'll probably need to do a little bit more research on this because it's just not something that I've done before and I'm not super familiar with it. So I just wanted to go back to Arc after not getting those to like maybe work the way I wanted to. So I just wanted to try making a cube now with like the base resample data. So with the hourly summaries, even though the like resample method was not the way that it should be, and not the way that we want the resample to be, but just trying to get it to work, just to see like if I can get a cube to load with the hourly summaries. So there's this really weird issue where if I resample and save as a CRF, a cloud reference format, it's not actually saving as a CRF, even if I like specify it to be our CRF. And it's not preserving the multidimensionality. So even though I've like saved this resample as resample.crf, when I try to create a space-time cube from it, it says it has to be a multi-dimensional CRF. Which in the past I wasn't having this problem. So it's either some sort of ARC bug or another kind of issue with our data where it's not pulling the time data correctly. So I went back over after doing this, and I tried that for a really long time. I went back over to Python and thought maybe it's got something to do with the timestamp. So the timestamp for this data was looking like this on the right. But then when I was bringing it into ARC, I realized that it was the NetCDF was like treating itself more like just a hyperspectral, like remote sensing image where each band was being set at like a piece of time instead of being like actually what we want it to be. So I went back to Python, and the original timestamps were year, month, date, and then hour. So after doing some research, it looks like ARC likes to have geodatabase formats in terms of timestamps as being year, month, date, hour, minute, second, like this. So I just did some more like string editing in Python to see if I could get it to pull that format exactly. So eventually the timestamps were looking like this, and then I just did some like string editing and list editing and got them to where they were in the like what should be the proper format, formatted exactly how it was listed back there. But ARC just was not, it wasn't happening this week. So we've got this meme. I managed to crash ARC probably a record number of times this week, upwards of probably 25 times.
Oh my God.
I don't know why. It was not having it with the data, but even after I fixed the time, I still had to like go in manually and say, yes, this data has a time dimension, and set the time dimension to be this like band called time. And I was hoping that when I would hit this calculate button, it would say, oh, look, here's the exact timestamps in the format that I like to see them. And it just, for some reason, didn't do that. So I had to manually enter like the time extent. And I played around with the time a lot and got it to where it looked like it should have been working with the hourly summaries and the time. But then when I go to either copy it over to a CRF format, export it to a CRF format, resample it and try to save it as a CRF, even if it has the file extension, it's not keeping the multidimensional properties. So there were two options, and one of them was the make netcdf raster layer. That one worked with the data so that like it was working with like, here's the time slices of the data, and that was good. And then when I tried to progress after that, it didn't work very well. And then there's the make multidimensional raster layer, which is like a slightly different tool. And when I use that one and bring in the netcdf, it has the data properties correct. And I think the time formatting is a little bit better, but it also doesn't keep any of the actual data itself. So I need to figure out how to either combine these methods or edit these methods. But I got a lot of the error 999999 something unexpected caused ArcGIS to fail this week. So yeah, I didn't actually make as much progress on that as I wanted to. And then the other thing that I did this week was Lindsay and I went to the CID and we got ground control points. So we collected 3 of them, and basically with those we were able to like finish aligning the CID exterior scan from like the GeoSLAM.
Awesome. That's a good photo.
Yeah, and then my goals are just enjoy spring break, and then I just want to figure out this space-time cube stuff. I'll get it at some point, I think.
That's good. Documenting what's not working is as important as figuring, you know, you have to document the whole journey, and that'll pay off in the long run. So thanks for that. Thanks for the update there. It's good.
Addison, have you tried saving the data in 12-hour time format? Because that's what, when you showed what it wanted, it had it as like AM, PM, and yours is in 24-hour time. So I mean, I don't know if that was breaking it or not, but like, there's a chance that it was trying to read it and just like freaked out and didn't have any kind of error catching.
It might be. I can try to figure out a way to do that maybe.
When you're doing the same thing, it just like a little if statement and then a mod by 12.
Yeah, so then like the first ones would be AM and the second one would be PM. Okay.
There's-
Yeah, I might
Yeah.
try that and see if that improves it.
And
So
there's
that's
formatting,
go ahead, I'm sorry.
there's formatting tools that you can use that'll do this interchange. So instead of doing it manually, you can actually just read those things in and then they come in as dates in Python and then you can just format them back out again however you want. So rather than sort of manually working with the strings, which works. Let's see. There's some examples in the NetCDF building code, I think, if you look at those, Addison, like
Okay.
how I'm reading those in and then reprocessing those. So that might give you some ideas for ways to do it instead of handling the strings themselves.
Like the datetime library or something
Yeah.
should probably have most libraries, because that's like a very standard
Yep.
form. So if you just be like print,
Yep.
it'll probably just do it.
Yep.
I was gonna say, like, I use R a lot and I use Lubridate because we have a lot of sensor data that all the dates, it's a bane of my existence when you have that. And I was laughing with you, not at you, when you were talking about crashing Arc. Like, I get it. But the whole thing with the time series, yeah, it's called Lubridate in R, where you basically, it does a lot of these conversions. And it's one of those where once you get it right, it's kind of hands off the keyboard, you know, you got good stuff from now on. So it's going to be one of those deals where take a sample set of data, throw it through. If Arc actually will eat it, then you know that you've got it for everything.
Yeah.
And I think once we get it figured out, we'll just add the production of these I don't know. I add the production of like a daily net CDF, like that aggregates that pares it down and then aggregates it so that all of these are just being produced every day.
Yeah.
It doesn't really solve the problem because as you're talking about the stuff, you know, the benefit of multidimensional data is that you should just be able to slice it. But I have a feeling that Arc's tools to do this are going to be pretty limited. In a perfect world, you just like aggregate them all together in a single net CDF that like had everything, and you could cut it by hour, you could cut it by day of the week, or you could cut it by month or whatever. We'll see where we get with that. But the work that you're doing is going to feed into like, how do we manufacture these so that they're good to go, right? Like,
Yeah.
we obviously don't want to be doing this every time, but once you get it figured out, then we'll just automate it and we'll just make them every, you know, we tend to process the logs like every 2 weeks. So it would be sort of like a 2-week cycle, but which by the way, they probably need to be updated.
Yeah, into that.
Okay.
One thing I was wondering about is like you're using the hourly summaries, right, Addison?
Yeah.
So for a D, we only have 24 images.
Hmm.
And I was kind of doing the same thing, but where I take all the images into ArcGIS and make the NetCDFs inside there. Because ArcGIS only likes the NetCDF it makes itself. And like I was trying to do the same thing, but I got lost in the GCS stuff.
Yeah, that's actually a good point. So, you know, in the programming class, we'll be talking a little bit more about ArcPy when we come back from break. But starting to use ArcPy to do the creation instead of trying to do it through the GUI might be faster because you'll spend less time chasing around boxes and setting little things. You can just, you know, control enter, and it's going to work or it's not going to work, but it'll probably save you some time. Very good. All right, did you want to talk, Kenyon?
Yeah, sure. So I don't have a presentation, but the big updates are like, as you already know, I defended my thesis, and also another big update is I submitted my ETD, the electronic dissertation. So it's on its way for approval. The graduate school will review it and approve it. So yeah, and other than that, I also received my geoinformation technology certificate as well.
Great.
Because I completed those courses and I just claimed for the certificate. And I think like all of you, like especially Shashank and Addison, the courses you're taking, and I think Lindsay, oh no, Lindsay's has to be like 5,000 more, like 4,000.
I think undergrads can't.
The undergrads can do that, yeah. So yeah, Addison and Shashank, you guys can claim that course as well. You just have to like check the course requirements. So that's when I got my diploma. It's beautiful. So
Congratulations.
thank you. And other than that, so I also I previously presented here. Like I'm basically trying to figure out like is there any difference in soil water retention between parallel and perpendicular plots in the farmlands, and the data I'm working with is from Texas. So previously I looked into like some indices like NDVI, NDWI, and trying to do time series analysis using Google Earth Engine. But from 2 weeks ago, I started working with soil moisture data, and I was trying to use like Sentinel data, like the radar data, the SAR, the synthetic aperture radar data. I didn't work with it, but seems like a long process of like processing that data and using it for soil moisture. So yeah, so maybe next few weeks I'll be working with that data, and it's going like I'm going through like a good learning process because I haven't like used that data before, but and like I'm also like using like ANOVA, which I already did for my research, to see like the differences, the data that I have for parallel and the perpendicular plots, and I'm trying to figure out like whether there are any differences within that. So I think like the reason I'm saying all of this because the things that I learned from my master's degree is actually like I'm like kind of seeing that it's taking action. Because it's more like a job that I'm doing. Like I have been given a problem, I'm trying to solve it with the skills that I've learned. So yeah, it's going well so far.
Great. Okay. Clay, did you want to do an update this week? You're always welcome and you're not required.
I appreciate it. I'm working with Dr. Sherzai over in Geosciences, and he basically gave me, I've got a lot to read. So I'm going through a lot of papers and just trying to get familiar with the INSAR process. He's setting up a computer over there that has MATLAB with a bunch of the processing for the INSAR data. So the plan is just to grab some freely available imagery around the plant site. And I found some interesting information about the plants. Was the current site where we're injecting 1 million, we're going to be the James River sites on the other side of the James River. That's going to be pumping 16 million when that comes online, I guess next year, I think. And then we're going to go back to the Nansemond plant, and they're going to go from 1 million up to 30 million. So they're going to make it a fully operational injection site. The thing that I find interesting is that that will be very close to that threshold that someone brought up in that land motion seminar that I went to about they don't know what's going to happen when we inject over 50 million, I think, a day in Hampton Roads. So that I find the whole process, there's a lot of room, I think, there for research. But
so was this whole line of thinking sort of inspired by fracking? Is that?
It actually wasn't. Dr. Charles Bott is, he actually teaches at Virginia Tech in the civil engineering department. And he's also the director of research and development at HRSD. And they have done wastewater injection before in other places, just not to this scale. Yeah. So it was kind of pretty ambitious to go, to take what started it. Actually, when I got hired 15 years ago at HRSD, it had to do with the consent decree that the EPA had come down on HRSD with. Because we're near sea level, they didn't want any sanitary sewer overflows going in the Chesapeake Bay or the ocean. So to stop that, what we did was we did a lot of billions of dollars worth of infrastructure improvements all over Hampton Roads, all the pipes. And what ended up happening was they realized that in 30 to 50 years, we're going to have to replace all this stuff all over again. Is there a better way to do this? And so what we found was that by treating the wastewater and then being able to directly inject that water into the ground, the clean water, it turned the nitrogen and phosphorus content, none of that effluent, that's the remnants after they clean the wastewater, none of that goes into the waterways. So at that point, you have nitrogen and phosphorus that can be processed for fertilizer or whatever else, but it's not going directly into the waterways. And so that kind of took the EPA out of it took us from being under the microscope of the EPA as much. If we have something that we're doing, it actually turns us into a water utility. If you really think about it, it's kind of a weird concept, but it has some similarities to fracking in the sense that it's an injection type of method, but obviously not as destructive. We hope that's not the plan. Our whole mission and vision is to help the environment, not to.
Right. Not in the effect. You guys are trying to do something benevolent instead of, but
Right.
the idea of injecting water the other question that I had is what are the expectations or the hopes for how much this is going to affect either the subsidence or so is the goal of this to just slow subsidence or is it to reverse it?
Ideally, it would be to reverse it. I think what they're gonna because of COVID and it slowed down a little bit of the construction that was going on. I think it's going to probably slow it initially. If they get up to 50 to 100 million gallons a day, I think you're going to find that it's either going to keep stabilize it or it's going to improve. It's going to come up. My first reaction was, yeah.
How much motion are we talking about here? Like on a what is the subsidence? What has the subsidence rate been over like let's call it a 10-year period? Are we talking like a centimeter, 20 centimeters?
So the extensometer we have at NANSM's been there since 2018. So I can actually, for the next meeting, I'll pull up the extensometer data and plot it for the last 5 years. But they have other extensometers around Hampton Roads, like I don't know if you guys have ever heard or smelled the Franklin paper mill that was once operational. Yeah, it smelled horrible. It smelled like rotten eggs every time you drove towards Emporia. The speed ticket capital of the world, if you guys don't know that. Yeah, they have an extensometer there and they've had it there for like 40 years. And so that one would have probably, you would know one way or the other. And that's how they originally found out that how bad I think the subsidence was between that and a combination of the INSAR data for the region. Mm-hmm. What Dr. Sherzai and I have kind of discussed, he feels that it's a good research topic, is the fact that rather than doing INSAR at a regional scale, which is typical, we're talking about getting as fine a grain imagery as we can possibly get, and then process that around a smaller area to see if you can see the same type of trend that you're seeing with the extensometers, or if we brought something else into play, whether it was traditional land surveying collection of benchmarks for vertical or LIDAR, any of these other methods to see if we can figure out if it is actually moving. The one thing that you brought up that has to come into play too, that I think Dr. Shao is skeptical of, is the fact that the movement isn't as much as, say, like Texas. They're used to land subsidence happening in centimeters per year. Whereas in Virginia, if we had movement in centimeters per year, it would be bad. It wouldn't, because of how low we are towards sea level. We have much more than Western Texas. It would be a much more grave situation. It is already pretty bad in the sense that sea level's rising and we are sinking. So, but I think that it's an ambitious plan. I think that it has some potential there to study what is going on and to try to figure out if it actually, using machine learning and that, with either R or Python, and being able to project out, if we increase that injection site from 1 million to 30 million, like they're talking about, if we do that and then extrapolate it over years, what might that look like? Mm-hmm. That's the other thing that we were thinking about. But
are there any like core stations that have been operating for a long time?
There are, and that's the kind of stuff that we're going to try to bring in all those other data sets and try to, I think, compare that trend, because they're not, the resolution on them are all very different. So you have to kind of look at when you graph them out over time. So when you're talking about space-time cubes and stuff like that, that's the kind of stuff that I've done a lot with sensor data over the last few years. And so that kind of stuff to me is interesting in the sense that now we're talking about, we've got some things we've got to kind of look at correlation. and see if there's the same intensity level is happening in those places.
Cool. Well, thanks, Clyde.
Yeah, no worries. You guys have a good day.
Yeah, so no meeting next week because it's spring break. So we'll see everybody the week after that. All right. See ya.